Thank you. Maria,
Maria. All right, everybody. We are now on Module 6. Today is Basic Stats. My first thought was there are a lot of slides in this lecture. I thought I might need to break this up. I wasn't sure this is the right place to put it, but in retrospect, I think it's exactly the right place, and it's actually a very good lecture. So it mostly is going to cover some very basic information about how we handle different variables and how we, well, you'll see. We begin with the idea of Pico, and we're going to do we'll be looking at a paper throughout this talk. Pico stands for, again, the patient, the intervention, the comparison, and the outcome. So the paper we're going to be dealing with is a paper from 2003. And the question is, for patients with advanced Alzheimer's disease, so that's who the patient is, does memantine, that's the intervention, as opposed to no memantine, that's the comparison, improve cognitive function, that's the outcome. Here's a paper, New England Journal, and this is from Reichsberg, and again, I think it's 2003. We're going to be dealing with this this graph repeatedly, and so you can see what this is. This is the study is 28 weeks long. People were randomly assigned to either get memantine or take placebo. We'll come back to it later as to what the measures are. And this sort of anticipates where this study is going to go. We're going to explore it in a great deal of detail. But this is our 2x2 table when we're done. And you can see that the patients who took memantine had a 29% response rate, and placebo was a 10% response rate. You can calculate the risk difference and the number needed to treat. But we're going to come back to all of this, and it's going to make much more sense later. This goes back to the notion of variable type that we talked about in the last couple lectures. A continuous variable, we said, is something like weight, blood pressure, temperature. These are things that can take any value whatsoever. A discrete variable can only take, as it says, discrete values. All right? It can be as simple as dichotomous, that is, yes or no, up or down, died or survived, or whatever you want. It can be ordinal, and we could think about the MRC grading system, power scale. You can also think about the Rankin score that we use so much in stroke. That's another ordinal scale. The stroke scale is an ordinal scale, that sort of thing. It has only discrete values. And then you can also have nominal variables where there's no number at all. And again, race might be your best example. It could also do with what parts of town a person lives in, or that sort of thing. Here we had a very simple, going back to our very first talk, we were looking at Bell's palsy, and we decided that either it was the patient had a good outcome or a poor outcome. That's an example of dichotomous variable. Again, the MRC grading system is familiar to you. Blood pressure. And the difference here is that blood pressure has a discrete distance between, so in other words, the difference between 50 and 25, right, is the same as between 125 and 100, right? That difference is the same. But if you took the MRC grading system, that would not be true, right? The distance between 2 and 3 is not the same as the distance between 4 and 5. We'll look at that, and I'll explain. We'll see that in a minute. The other thing I want to talk about, though, is that while these are intervals, there is one yet higher level, if you will, of interval variable, and that is what's called a ratio variable. So, for instance, if I said, think in terms of temperature for a minute. If I said 200 degrees, I have a person with 200 degrees, or I make a measurement, and the answer is one measurement is 200 degrees Fahrenheit, and the other measurement is 100 degrees Fahrenheit. right? So is 200 degrees Fahrenheit twice the temperature of 100 degrees Fahrenheit? See, it's not. Why? Because absolute zero is minus 470. But if I said 200 degrees Kelvin and 100 degrees Kelvin, right? Is 200 degrees Kelvin twice as much as 100 degrees Kelvin? The answer is that it is. That because there's a true zero, you can have a ratio, okay? That is true for blood pressure. It's not true for temperature, depending on the scale. All right, and here's the point, is that when you look at the MRC scale, you see that the interval is not equal. Most of the force, if you were to somehow measure force, most of the force change is between 4 and 5. All right. Well, let's pick this up again.
This computer.
Yeah, I know.
Yeah, usually the computer says, like, this is not working, not working. You changed it already. We call it this morning.
Nope. We're just gonna keep going through this. All right, this is where we were, all right? So most of the distances between level 4 and 5 on the MRC grading scale. All right, so let's just look at this. We have nominal, we have ordinal, and interval, again. Now, when we start comparing studies and we measure the variable twice, we create two groups, with memantine, without memantine, with steroids and without steroids, whatever it is, okay, with TPA, without TPA. The question is, how can you compare the two groups? If you have a nominal scale that is, only two possibilities, all right, or if you have gender or race, then all that you can do is when you compare the two groups, you can say they're the same or they're different, and that's all there is to it. You can't say that one is more than the other, that somehow Caucasian is more than Asian. It's like, that doesn't make any sense at all, okay? You could, right? If you have ordinal data, you can say that they're different, but you also could say that one is either greater than or less than the other. So let's say that we had the MRC score of 4 and an MRC score of 3. Though definitely 4 is greater than 3, right? And we're gonna look at this in more detail. When you do an interval scale, you can actually talk about the magnitude of the difference. You can talk about the magnitude. You cannot talk about the magnitude of the MRC scale because the distance from 2 to 3 and the distance from 3 to 4 or 4 to 5 are not equal, right? So an interval gives you the magnitude of the difference. Right? So that's all just by way of starting. Now that's the introduction. For any group, no matter what the variable, whether it's a nominal variable or an ordinal variable or an interval variable, you want to be able to say two things when you make a measurement in a population. You want to say, what's the central tendency of that population? Okay? And what's the dispersion of the measurement within that population? So think in terms of a Gaussian curve if you want for a minute. The peak that's the mean, right? And that's going to be your average, if you will. And then you can take the distribution of the Gaussian as your distribution. But the question is, what do you do when you're dealing with a nominal scale? What's your central tendency? What's your measure of dispersion? And the same thing for an ordinal scale. Well, how do you describe the central tendency and the dispersion? And these are important because eventually we're going to want to compare two groups. All right. So here you are. This is a categorical scale where the outcome, right, the measurement that we make, this would be from a case control study, let's say, is ethnicity. And we have here, what do we got? 6. In this study, it looks like 6 Hispanics, 5 African, 5 European, and 3 Asian, all right? How do you describe the central tendency of this? The answer is you use the mode. The only thing that you can do is you can say which group had the most patients in it, the most subjects in it. That's the mode. That is the group with the largest number, and that's all there is to it. And the only measure of dispersion that you have is the proportion of people who are in that group. So the mode is Hispanic, and 32% of the people were Hispanic. And that's all that you can say about a categorical variable as an outcome variable. Okay? When you progress to a fixed order, an ordinal scale, all right? So this is what the ordinal scale actually looks like for the MRC. So here we just put the numbers. But here, this would be the scale of the amount of force that's generated by each of that correlates with each of these scale numbers. And you can see that this is not at all linear, if you will. The interval between them is not constant. All right. So then what do you do when you're dealing with an ordinal scale that doesn't have a constant interval? And you can see this and you can look at it, and the answer is you can take the median. All right? And that's what you do. So the mode is what you're going to do when you're dealing with a categorical variable. The median is the correct central tendency when you're dealing with an ordinal variable. Median. And what is its dispersion? You take the interquartile distance as the dispersion. Okay? So what is a quartile? When you say we're going to take, you got 200 people. Here's a question for you. I got 200 people in the group, right? How many people in the top quartile?
50.
Yeah, 50. I mean, that's the way you set it up. That's exactly what you do with a quartile. You say, okay, well, I'm going to divide the entire group into 4 groups or 3 groups if you want to do tertiles, right? Or quintiles, or whatever you want. You say, I'm going to divide the group into 4 groups, and I'm going to find the numbers which define the top 25%, the next 25%, the next 25%, and the last 25%. That's exactly what you do with an interquartile distance. So I inserted this slide here this morning. All right. So this is just a simple way of looking at it. All right. This is just what we said. You're going to divide the whole group into 25. So if your axis is all 200 people, then these will be equal in size, right? And this will be in the middle. Okay. So let's stay with this. This is now the interquartile range. That's the difference between the divider for Q3 and the divider for Q1. So this number and minus this number. That is your interquartile range. Now it looks like it's going to be an even number, but it won't necessarily be even, because in this case we just put the 200 people. But look here, okay? It doesn't have to be centered. And they don't have to, the 2 boxes do not have to be equal in size at all. Okay? So you follow what I'm saying? Now there's more to this. When you display this is what it's going to look like. And I'm putting it here on the horizontal. Here's your upper quartile, there's your lower quartile. Q3 minus Q1 is the interquartile range. This is a definition. This is how you measure dispersion in an ordinal scale. Now, what do you call these 2 guys when you see this? Because you'll see these plots. This is known as a whisker plot, and it's called a whisker plot because these are the whiskers out here. Okay, and this gives you what's going on in here. This has all of the data. This is your whiskers include all of the data except outliers. Numbers that are so far away that you wouldn't even want to calculate them in the big group, okay? So this is called a whisker plot, okay? And this is how it's set up. If you go back and look at this is the one to look at, okay, on this slide. That is the lower left corner. All right. When you're dealing with a fixed interval, and in this case we're looking at time, so weeks is simple. This is the time to recovery of the facial palsy. And here, when you're dealing with a fixed interval, then you can take the mean, and of course, the standard deviation becomes the measure of dispersion. Okay? So you're dealing with mode and proportion. I think actually the next slide summarizes it, right? When you're dealing with categorical, it's mode and proportion. When you're dealing with ordinal, it's median and percentile into quartile range. When you're dealing with the interval, you're taking mean and the standard deviation. Now, it is common, it is very common to merge these groups. Now, and you notice the arrow on the right shows you the direction of by which you can merge. You cannot get from, let's say, an ordinal scale to an interval scale. You can collapse the interval scale if you want into ordinal scale or categorical scale if you want. We do this with the NIH, with, let's say, with the Rankin, right? The Rankin is as we said, it's a ordinal scale, 0 to 6. But very often, we say independent or not independent. We're independent as 0, 1, or 2, and okay. And there we do. We just collapse it into a dichotomous variable, which is useful. Number one, you can do a 2x2 table. Number two, when we get to logistic regression, so you want to predict the likelihood that a person's going to survive, or you want to predict the likelihood that they become independent. Again, the math is not there to use 0, 1, or 2. You don't predict 0, 1, or 2. You predict either that they do or don't. Logistic regression is you're predicting yes or no. It's a dichotomous variable when you use logistic regression. So you want to be able to collapse them. So you can always collapse by grouping that way. Here's the quadruped score, and here we divided it up into anti-gravity or not anti-gravity, right? So you can always move in that direction if you want by defining it. Now you have the dichotomous categorical scale. All right, and then of course what you deal with is proportions, and that can be very useful because you can deal with it statistically and look and see if there's a difference between two groups. All right, as you see in the direction of arrow, you are gaining ease of interpretation and ease of analysis, but you are, without any question, losing information. All right? All of those, then, what we just talked about up until this slide, then, is how you describe a central tendency and dispersion within a single group. Right? But now, we want to compare groups. We didn't talk about comparing groups, right? We only talked about the group itself. So now we want to compare groups. And for all practical purposes, that means we want to get to a 2x2 table. And you remember this is the data that we used from the facial palsy. And you remember this data, and we did this analysis of it. So now we could also look at it in a different way, all right, by doing what you have is a categorical by categorical. So now the question is, what are the groups? Are the groups intervals? So you have two things now. You have your outcome variable. Your outcome variable can be categorical, ordinal, or interval. But you also, so that's your outcome variable. That's what you measure. But your groups could also be nominal, categorical, or ordinal, or interval. So for instance, you say, how would you get an interval group? You say, well, this is week 1. This is the people who started week 2. I mean, you do that with a race, right? These are the people who started within the first 10 minutes, that sort of thing. Of course, so in the case that we're looking at here with a facial palsy with steroids, we had good outcome, bad outcome, so that's categorical. We had got steroids, didn't get steroids, that's also categorical. So then this is an example of how you compare two groups, categorical, and the outcome also is categorical. So this is what we call categorical by categorical. And you measure the proportions, right? So that's what we did. We measured the proportion of people with a good outcome in the steroid group and the proportion of people with a good outcome in the no steroid group. The nice thing about it, and this is what's surprising, for such a very simple way of thinking, what we got was a very useful measure, and that is the risk difference. And we could take the ratio or the absolute risk difference. And this became very useful, okay? So you can see that we have this mode. Let me see if I can get my here, right? Nope. I should have known better. So our descriptive statistics is the mode and the proportion. Our measure of association between two groups is the relative risk and the risk difference. And in order to calculate the chance, the probability that this could have occurred by chance alone, we use what are called non-parametric statistics. We can use chi-square or Fisher's exact test. We're not getting into that right now. The point is that there is a way of measuring the probability that any differences that were observed are more than attributable to chance. Now here we take a different matter. Here our groups are categorical, making it up. This is treated versus untreated, but our outcome scale is ordinal, okay? So this we're calling ordinal by categorical. And so we can take the median of each group, and we can take the interquartile range of each group, all right? And that's what's done here. There's your whisker plot. There's no whisker down because 0 is the bottom of the scale, so there is no ability to go below. You can take the difference of the medians. That's what we've got. Our two medians here. We can take the difference of the medians, all right? And so our descriptive statistics are the median and the interquartile distance, and the measure of association is a rank analysis of the difference of the median. And this is analyzed with tests that are known as Wilcoxon and Kruskal-Wallis, depending on how many groups you have. And you go to the book and you look up the formula and you plug in your numbers, and it gives you an answer that the difference that's observed is related to chance or beyond that of chance. Okay, this is ordinal by categorical. All right, this is back to this is here a case now where we've got an interval scale, right? We're going to flip this up. All right, so now we're looking at the two groups, steroids and not steroids. That's categorical. We're going to look at the interval, the number of weeks until they recovered. All right, so if it's an interval, we get the mean and standard deviation. And then the comparison is going to be the difference between the means, right? And that's a good number, right? And so the description is the mean, right? The standard deviation or standard error. The measure of association is the difference between the means. And the tests that we use are, depending on how many groups we're comparing now, the t-test or ANOVA, analysis of variance. Now, what happens when you get to ordinal by ordinal? Okay, where your grouping has a sequence and your outcome variable also has a sequence, and they're both intervals. Then you're doing interval by interval, and that's when you start making a graph. And obviously, you take the slope of that line, and that's what you do, is you actually measure the slope. All right? So then when you look at this group, you have the mean and the standard deviation are your descriptive statistics. Your measures of association are either the slope or a correlation coefficient, depending on the group, the type of variable that you're dealing with. Because you could be doing also ordinal by ordinal if you want. And the t-test is your usual statistic. Okay? So this is a summary. So let's just stay here for a minute. The Spearman correlation coefficient, if you look at those, you have the Pearson correlation coefficient, and they're just, you use a different test depending on the data type that you're working with. And you look it up. You don't have to remember any of this. The point is that you do draw a correlation coefficient, okay? And that can be done with ordinal versus ordinal. When would you use ordinal versus ordinal? Let's say that when
we did the aspects study.
That's exactly what I was thinking. Radiology uses, so you can use the aspect score.
So we correlated the reading from one to the other,
right?
And we used Spearman correlation
yep.
because it was ordinal.
And these are very useful correlations, and so, and the Wilcoxon and the Quartile-Wallace are incredibly useful, where you're dealing with an ordinal scale, all right, and categorical groups. Okay, that's just tremendously useful to use Wilcoxon and Quartile-Wallace. Okay, and these are very, very powerful statistics, by the way. They make great use of the data. They don't waste a lot of information. They really optimize your ability to see what's going on. All right, and that's what makes them so powerful. You want to use the right test, because the right test will give you the most discrimination in your analysis, and that's what you want to do. There are other ways of doing this study. So I mentioned how Janet and my sister will try very hard to get to a pre and post test. That is where each individual becomes their own comparison. So these are now, when you have that sort of thing, or where you take two people from the beginning and say, you take twins, right? And you say, here, you go in one group and you go in the other group. Those people are paired now. You don't want to just throw them in with the rest of the population. You only want to compare the pre to the post, or twin A to twin B. So those are paired. Those are much more powerful statistics, because now you're comparing the two, and your outcome is actually the difference between the two. And it eliminates a lot of noise. This study, this Memantine study, is paired, okay? So it's the comparison of what they look like at 28 weeks to compare to what they look like at baseline. So that's nature. So maybe if we're going to get into that, maybe I almost hesitate to take this down. These are the proportions of people who did or didn't improve. Let me, without going to the paper, let me tell you what they did. So in this study, they recruited patients with advanced Alzheimer's disease from their cognitive disorders clinic. All right, that's the first thing. They then took everybody and they gave them 2 test batteries. One called, I think, the CIBC, and the other one called the 80-something or other. They were both, like the Mini-Mental Status exam. They both were scored on ordinal scores, okay? And I'll show you what their ordinal score was in a minute. They then compared the baseline, okay, to a repeat test at 28 weeks. And in what they did was they actually did a pre and post test for them. And they either randomized them into the 2 groups, or they did a washout series where all patients both got treated or got placebo. All right? And then they looked at baseline to 28 weeks. And they asked a very simple question. Did they respond? Response was, there were 7 categories of response. Category 7, I think, was they improved a lot. Category 5 was they improved. Category 4 was they improved a little bit. Category 4 was there was no difference between baseline and 28 weeks. And then it went down. 23 was they got a little worse. 3 was they got a little worse. 2 was they got worse. 1 was they got much worse. Okay, so that's the scale. It's a 1 to 7 scale. That was, and was a comparison, like I said, between 28 weeks and 0 with or without Memantine. They considered a response if the patient did not get worse. So they didn't have to get better. If they didn't get worse, then they're considered a responder. Okay? And this was the data. So while they were taking study drug, 23% of them had a response, and if they weren't, then 57%. So that's how. Whereas the people who only a small, very small percentage didn't respond while they were taking the medication. When you do paired, just like we looked at the appropriate tests to use, Quartile-Wallace or Wilcoxon or whatever, this is what you do when you have a paired tests. And when you're dealing with categorical, or ordinal, or interval data. Okay. I'm almost hesitant to get into this. This is for another time. Each of these is almost their own lecture that we will be having later in the course. But it's maybe just useful to say it once, and that is when you're dealing with only one outcome variable and one predictor variable, and the predictor can only take two values, then t-test is the correct test to use. When you have one out, so the question is, when do you use ANOVA and when do you use MANOVA? ANOVA is when you have one outcome variable and one predictor variable, all right? But the predictor variable can take on more than one value, all right? So the outcome variable is survival, right? They survived or they didn't. The predictor variable is whether they were treated okay, category number one, here's a predictor variable. These people didn't get the drug at all. Category two, they got the drug, but when we measured their level, it didn't get into the therapeutic range. Category three is we gave them the drug and their level went into the therapeutic range. Okay? And the question is, does the drug make any difference? Okay? So now you have three different values that the predictor variable can take, and that's it for the outcome variable. Now, on the other hand, you could have one outcome variable and more than two predictor variables. That is, whether they took the drug, what their baseline level was, that sort of thing. When you have multiple predictable variables, that's when you use MANOVA, multiple analysis of variance. All right. Now we're back to this. Okay, so here's our study. Now, here's my question. As you look at this, does this look statistically significant to you? It sort of does. You have these intervals at 28 weeks, they're non-overlapping. Does it look clinically significant to you? There's CIBC plus went from the difference here at 28 weeks is 4.35 versus 4.7.
Things that if you see the score, the global score on the left, the interval in between is like 0.2, 0.2, 0.2. So if you, I don't know, I know that if you go to the table, we're gonna see like the difference between week 12 and week 28 is gonna be like 0.1. So maybe if we see it in the graph, because of the way that it's designed, you might think it's significant, but when you see the actual numbers, and it might not, because here so it worsened, right? And so it was by 0.2. So by between week 12 and week 28, the ones that use memantine worsened less than the ones with placebo by how much? So you can tell how much. It might be 0.1, 0.2 compared to placebo that was maybe 0.5.
So first, I mean, I agree with all of that. So the civic is like the mini mental status, right? So is that ordinal or interval? Ordinal. And if it's ordinal, what's the appropriate central measure of the central tendency? Median, right. Right. Look what they did. So here's the score. Here's the civic score. All right. Right. So this is what they're doing. So this is ordinal. All right. And we're doing ordinal versus, ordinal by categorical. Right. So this is what it should look like. This is what we said. Look at what they did. This is the New England Journal of Medicine. Okay. Okay. This is nonsense. Okay. And if you did, this is what they reported because they're doing, so this is what they reported. It was 4.4 versus 4.7 with a value of 0.03. So when you talk to the patients, what are you going to tell them with this data in your hand, the way the authors said it? Is it good? Look at the confidence intervals, the standard deviations of 1.12 and that sort of thing. So it's a p-value is less than 0.05, so it's statistically significant. But you have no idea what to tell a patient. Watch what would have happened if they had done this properly. So instead of doing this, you would have had this. You would have gone to the 2x2 table that we started this talk with. And you would have seen a 30% response rate over a 10% response rate. And the difference in response rate is 20%. And the number needed to treat is 5. And you could say that for every, or think to yourself, that every 5 people that are treated with memantine, one of them is going to have their disease stabilized over a 28-week period. Now you can think about whether you want to use the drug and compare it to the side effects that it has. As it turns out, there was no increase in adverse events at all. So there's no downside. So as a result of this one, where they used the wrong statistics, you think you're using a powerful statistic, they used the mean and standard deviation. That was the wrong thing to do. And not only that, it was useless. It masked the useful information. So it's wrong. That's what I'm saying. You got to use the right information. And if at all possible, when you're trying to analyze a study, see if you can get down to a 2x2 table. Because if you do, it becomes almost immediately obvious to you what the answer of the study is. Okay? And that's it.
Thank you so
All
much.
right. Finished by 1 o'clock.
Yeah.
78 slides. Very late.
Stephen was listening to this.
It's all, gonna be started. Right. It's all good to go. You just
Okay.
Yes, thank you.
So, Eli, just one more time. So, what did we decide? Monday, Annie's free, right? Tuesday, she's going to get 2 patients. All right. The next week after that, right? We said we're going to do 5 or 2 residents, 3 and 2. Yeah.
So the one that has 2,
We'll
which
cover
so,
2 counts.
yeah, and let's finalize that. So we will know which one. I'll tell you. So the next week, the 2 residents would be Maria and Steven.
Okay.
So both seniors. Okay, so they can.
Okay.
Yeah.
Okay. Thank you.
So let me just, so I can add it to the schedule and they will know who will be on call for 2 guys.
Right. Okay. Great.
Okay, and I'll send it now.
Thank you.
Thank you, sir.